Hi everybody, it's your old pal Mr. Cook. We're going to do some difference quotient problems. First what we need to do is identify the functions that we're going to be using here for number 57, 58, 59, and 60. For number 57, we're using the f function, the lowercase f function, and we get that from the previous problems, 41 through 56. And then this one we're using the capital F function, so that means that we're going to be using this one over here, again from the same problem set. The lowercase g function is over here, so we're going to be using that with this one. And then the uppercase g function is this one, so we're definitely going to be doing that over there. Okay, so let's do them one at a time. Let's start with number 57. So for number 57, we're using the f function. So that's this one right up here, so let's write it out. So we have it on our piece of paper, f of x is equal to 2x minus 3. And we need to do the difference quotient with it, all right? So we're going to write that on there as well. F of x plus h minus f of x over h. Okay, so let's get the book out of the way real quick and let's get to work on this thing. All right, so the difference quotient, what you need to do to be successful with working with difference quotient problems is recognize first off that this second part over here is going to be the original function that we start off with. So this 2x plus 3. Whatever we get with our original function is literally just going to go right on over there, okay? But you have to watch out for one thing, and that's this. Since we're subtracting away the entire function, you've got to make sure that you put parentheses on there, okay? And in fact, if you want, you can just start putting together your difference quotient a little separately, just in the pieces that you start putting together. So we know we're going to be subtracting away that entire function, so we're going to put parentheses around it and then write out 2x minus 3 right there. Another thing that's never going to change is this h value over here. So h just goes in the denominator like so. The lone difficult part about this, before you start your simplifying and subtracting, combining like terms, all that stuff, is the f of x plus h. So let's go over what this means. So f of x plus h, all it means, like when you see this, it just means you take the f function and instead of x's, wherever you see an x, like how we see an x over here, right here, we're going to replace that x value with this, x plus h. Okay, so you literally just plug it in. So in other words, f of x plus h, the thing that we're looking for to plug in over here for a difference quotient, you just repeat the same exact equation, 2x minus 3, but instead of x, you're putting in x plus h. All right, so let's distribute in here. So 2 times x is 2x. 2 times h, if we distribute it in, is 2h, so plus 2h. And then we have that minus 3 at the very end there. Now, this is as good as we can get because we can't combine any like terms. No more x values, there's no more h values anywhere, and there's no more constant values either. So this is essentially just the function that we're going to be using of f of x plus h. Okay. So now that we've found f of x plus h, we're going to put it in this part of the difference quotient. So the part that we're subtracting away, we already have. We need to figure out what this part is, and we've already found it. It's just 2x plus 2h minus 3. So we're going to replace the f of x plus h part of the difference quotient with the equation that we just wrote out. So 2x plus 2h minus 3. All right. So from here, it's pretty easy. All you have to do is distribute your negative in and then combine like terms and then just sort of evaluate the problem. Okay, this really was the hard part. And you could even make the argument that it's not really that bad once you understand what it means. You're just, plugging in x plus h wherever you see an x on the original function. That's it. It gets a little bit more interesting when we do the quadratics. So number 58 and also number 60. When we see those, it'll take on a little bit more difficulty, but not too much. It'll still be pretty easy. Okay, anyways, let's finish evaluating this. So we're going to distribute the negative to the x and the negative 3, and we get the following. So 2x plus 2h minus 3, and then negative 2x and then negative times the negative is a positive, so that negative 3 turns into a positive 3. All right. So one thing I said in class is that a lot of stuff's going to cancel out when you do the difference quotient. And the reason that that's the case is because f of x and f of x plus h are very, very similar functions. You know, we're just changing the input value just a little bit. So since they're basically the same type of function, any constant values will cancel out, and also the lone x value should cancel out as well, leaving just values with h's in it. We'll see that the more that we practice these, but that's just kind of something to look forward to. Anyways, you should have spotted a couple of things to cancel out. We have a 2x here and a negative 2x here, so those, you know, add up to 0, so they essentially cancel out. We have a negative 3 and a positive 3. Those again add up to 0, so they essentially cancel out. And we just have this 2h all alone on top, and then just an h in the bottom, in the denominator. So when we divide out the h's, all we're left with is just 2, and that's our answer. That's our difference quotient.